Hello everyone, in this video let's discuss about the binary tree and its properties. So if we see at the binary tree, the tree with nodes having maximum two child or two children. So if you consider a node, this node can have 0 child or 1 child or 2 child. So this is the maximum. More than 2 child it cannot have. If I consider this is having 3 child nodes. So this is not a binary tree. So this is binary tree because it is having 2 children. Whether this is a binary tree? Yes, because it is having 0 child node. This is a binary tree? Yes, it is having 1 child node, like this. It can have 0 child node, 1 child node, 2 child node, not more than 2 child nodes. So if I consider a binary tree like this, so for example I will be taking, using this let's discuss about the height, level and other terms of the binary tree. So first, this will be called as the root node. So from the root node all other nodes will be originated. Now let's check out the value of the levels. So this will be called as level 0, where the root node will be in the level 0. Next, level 1. These all will be in the level 2. These all will be in the level 3. Like this. Level will keep on increasing like this. But the height will increase like this. That is, height is equal to 0. This is 0 height. This is height 1. This is height 2. This is height 3. So therefore, you can say the level will increase in the downside and the height will increase towards the upside. So these all the nodes which are having no children, nodes with no children can be called as the leaf node. Leaf nodes will not have the children. So if you see, the height of the tree is equal to height of root node, because root node value is 3, only one value will be there, because root node can be only 1. So height of the tree, complete height of the tree will be the value of the root node's height. Next, if we see the properties of the binary tree, so let's first discuss the properties, then discuss the types of binary tree. So we have 3 major properties. First one is maximum nodes at any level I. Maximum nodes at any level I is equal to any level I. So level I, for example, let's take level 2. Let's take the level 2. So what will be the maximum nodes at level 2? 2 power I. 2 power I will be the value of the maximum nodes at any level. So let I value is equal to 2. That is, let's check at level 2 how many value of the nodes will be there. Maximum nodes. Therefore, substitute the I value as 2. 2 power 2 which is equal to 4. See, 1, 2, 3, 4. At level 2 there are 4 nodes at the level. Next, second property is maximum nodes at height h. Maximum nodes at height h. At height h, what will be the maximum number of nodes? So its formula is 2 power h plus 1 minus 1. So if I consider, let h value is equal to 2. H value is equal to 2. So what will it be? H value is equal to 2 I took. Therefore 2 power 2 plus 1 minus 1. 2 power 2 plus 1 is 3. 2 power 3 is 8. Therefore 8 minus 1 which is equal to 7. So this is the small subtree. So this is the small tree which is having the less number of levels and less height. If you increase the height, the maximum to the maximum nodes at the height h can be equal to 2 power h plus 1. So if you took the height as 2, if you took the height as 2, the maximum number, the tree is bigger. So if its height is around 17 or 18, for example, that like means then the value will also increase now. So at the height 2, if you increase the tree height, then more number of the nodes will be coming. Therefore, the maximum number of nodes at the height 2 can be equal to 7, like that. Now, minimum node. We discussed about the maximum node. What will be the minimum node? Minimum nodes. So, the minimum nodes can be equal to h plus 1. So, if you consider the height 2, minimum node can be equal to 3. Now, let us look at the maximum height if node is given. So, the third property is maximum height if node is given. So they will tell at this node what is the height, like that. If they ask means the value will be equal to n minus 1. What is n? The node number. If they will give the node number, like that, n value is the node number, n minus 1 will be the height of the node. Next, minimum height of the node is given. Minimum height, if the node is given, its value will be log 2 n plus 1 minus 1. That is log into n plus 1, log base is 2 minus 1. So this will be the value of the minimum height of the tree if the node value is given. Now let's discuss the types of the binary tree. So the types of binary tree are, there are 4 types. If we discuss the types of binary tree, first one is full binary tree. You can also call it as proper binary tree or strict binary tree. So these are all the same name: full binary tree, proper binary tree or strict binary tree. So in this there will be 0 or 2 children. So I said in binary tree you can have 0 child, 1 child or 2 children. But in this full or proper or strict binary tree, there will be only allowance for 0 child, that is leaf node, or 2 child. Only this is allowed. So for example, here if you see, this is having 2 child, this is having 0 child, this is having 2 child, this is having 0 child, this is having 0 child. This is the proper or full binary tree. Next, complete binary tree. Complete binary tree. So in this complete binary tree, all the levels must be completely filled. All levels must be completely filled. So that is, we looked at the value of the levels. So if I consider level 3 must be completely filled. If it is completely filled with the nodes, then we can call the binary tree as the complete binary tree. Now, the third one is perfect binary tree. Third one is perfect binary tree. In perfect binary tree, all the internal nodes must have 2 children. All the internal nodes must have 2 children. That is, if you see this one, these are the internal nodes. This is root node, these are the leaf node. These are the internal nodes. Each internal node must be having 2 children. So then we can call the binary tree as the perfect binary tree. Next, last one, and the fourth one is degenerate binary tree. Degenerate binary tree. In degenerate binary tree, all nodes will be having 1 child. All nodes will be having 1 child. So if you draw 1 child, you cannot draw it to the right hand side. So the children must be as left as possible. That is, the single children must be drawn in the left side. While drawing the binary tree also, what you should do is first write the left side, then you must write the right side node, like that only. First write the left side node, then you must write the right side node. So hope you understood the concept of the binary tree, their properties and the types. If you have any doubt, please comment below. Please subscribe and support us. Thank you.